Okay, last section we focused on multiplying a polynomial by a monomial. And again, that was a lot of drill and practice just to review how to distribute as well as how to multiply two exponents together. Now let's review by just simplifying this polynomial. A couple vocab words. Remember that we are multiplying a monomial through a polynomial, more specifically a binomial, because there are two terms. One term, two terms. So when we did that, we realized we were multiplying that 4x by a 2x squared. We were multiplying the negative 5 by the 2x squared. And this step right here is optional. If students are very comfortable with multiplying exponents together, they can see visually up here, I'm multiplying a 4 and a 2 to get an 8. I am multiplying an x to the first and an x squared. Adding those two exponents together, I get x to the third. Negative 5 times 2 is a negative 10. And then we just have an x squared. Okay, so again, two little mini problems set up in there. Now we're going to look at something a little bit more extensive, and I did put the steps over here. We're comparing now multiplying a binomial through. Now we have two terms that we have to distribute. So looking at my steps over here, we have to distribute both of the terms of the first binomial to all of the terms of the second polynomial. And I did call this a polynomial because most of the time we're going to be dealing with binomials, but later when we get used to it, we are going to start seeing polynomials, so more than two terms. So many of the times, again, when we looked at distributing, we would put arrows. So the first thing that I'm going to do is focus on knowing that I have to distribute that x through both terms. Then I'm going to look at that 2, and I know I'm going to have to distribute that 2 through. So notice now I actually have 4 little mini problems. I have this x, and I'm distributing an x through to it. I have a positive 7, and I'm distributing an x to it. Okay. Then I'm going to look at, I'm going to move this over so I have room. Then I'm going to look at that x, and now I'm distributing a 2 through it to it. And that 7, I'm distributing a 2 through. Okay, so now let's go ahead and simplify that. X times x is x squared plus a 7x. Remember, we like to keep that coefficient first, so we're going to say plus the 2x and then plus a 14. Last step then, we do combine like terms. 95% of the time, those two middle terms, we will have to combine. So we're left with an x squared, a positive 9x, and a positive 14. So when you have two binomials that you're multiplying together, look what happens. We multiply them, we end up with a trinomial. Almost all of the time, two binomials multiplied together will give you a trinomial. Okay, so this is the horizontal way to look at this. We could actually set it up vertically. So we have x minus 4 times x plus 6. And this brings us back in the days where we multiplied two-digit numbers. So let's go ahead and do this. Remember multiplying two-digit numbers. We multiply the first two terms together. So 6 times negative 4 is negative 24. Then we multiply across 6 times x is 6x. Then to multiply the 10-digit number, if you remember, we put a 0 there. We multiply it across. X times negative 4 is a negative 4x. And then x times x is an x squared. The nice thing about this is it is set up perfectly. So all I have to do is go ahead and straight down. Negative 24 plus 0 is negative 24. 6 plus the negative 4x is a positive 2x. And then we just have our x squared. So two different ways to look at that. Okay, whichever way you think helps you stay organized. I actually like just the arrows, especially on a problem like this one. So let's go ahead and look at this last one and see how this is going to be a little bit different. For 1, we have coefficients out there, and for 2, we have an x squared here and just an x here. Okay, so let's go ahead and see what that does. We have a 2x squared times a 4x. So I'm going to skip this step and just know 2 times 4 is 8. x squared times x is x to the third. 2 times the negative 5 is negative 10, and then I have an x squared. Okay, now we're going to look at multiplying a 1 through. 1 times 4x is a positive 4x. 1 times negative 5 is a negative 5. So notice how this one is a little bit different. Here it says combine like terms. Well, let's look at this. We have no terms to combine. So again, this is that 5% of the time where because we started with two different coefficients, then we actually are going to have a polynomial that has 4 terms, degree of 3, leading coefficient of 8. Okay, got nothing that we can do with him, so we're just going to keep him. So these type of problems probably do work a little bit better horizontally because it would be hard to set them up on top of each other where we can combine like terms. Okay, but that's the concepts that we're going to be working on. Now setting up little mini problems inside where we're going to multiply two binomials together using that distributive property. Okay, go ahead and get out the notes and vocab for this section. Okay, objectives now are to multiply mostly two binomials. We will look at polynomials a little bit later. Again, a lot of drill and practice here. So just bear with me so we can get this solid concept in our mind. So that way when we do start looking at story problems, we understand quickly how to solve it. So example 1, again, we're using the distributive property when we're multiplying two binomials. So let's get those arrows going. And again, we understand that we have to multiply that 2x to each term, that 3 to each term. So for this first one, I am going to write it out so we remember what we're doing. We are multiplying a 2x to both the x and the positive 5 of that second term. Now we are multiplying a 3 by the x and the positive 5 of the second term. Simplifying that down, 2x squared plus the 10x. Again, I'm going to flip-flop these. I'm going to make it a 3x, a positive 3x, and a positive 15. Next step was to combine those like terms. So I have a 2x squared, and then remember that I add the coefficients. I keep the base, and then I add my 15. Okay. Remember that that first step here isn't required, but if students struggle with multiplying exponents together, you might want them to do that just to start with. Okay. I'm going to go ahead and set B up vertically, just as practice with that one. Okay. Remember, we're multiplying straight up, so 4 times a negative 2 is a negative 8. 4 times an x is a positive 4x. I'm going to drop my 0 there, and then I'm going to multiply across. 3x times a negative 2 is a negative 6x. And then a 3x times an x is a 3x squared. So two different ways to solve these, or to not really solve them, but to simplify them. End up with a negative 8, negative 2x, and a 3x squared. Both strategies will get you the correct answer. It's just whichever one you feel most comfortable with. So go ahead and try guided practice 1. And there we have it. One thing, if you do decide to do the vertical method, remember right here when we have 40y minus a 2y, that's 38y. But again, we always have to say in our mind that it's a positive 38y because we do have to understand that we are combining these terms together. So we do need to have that addition sign right there. Okay, so I showed you two different strategies on how to do that using the distributive property and the vertical method. One way to look at this, they call it the FOIL method, because if you notice, what we're doing is we're multiplying the first terms together, then the outside terms together, then the inside terms together, then the last terms together. So again, a third way that you can think about that. First, outsides, insides, and last. That's exactly what we do with using the distributive property, but sometimes having a nice little mnemonic device to help you stay focused does work as well. So if you hear use the FOIL method to simplify these two binomials, that's what they're meaning. First, outsides, insides, last. Okay, so example 2, again, use that FOIL method. So we're going to see this as first. Then we are going to multiply the outsides. Then we're going to multiply the insides. And then the last. So we have first, whoops, I have my colors wrong. Come on, erase please. So again, first and outside and inside and then last. Same concept that we just did. Okay, so let's do this. First, give us 6y squared. Outside terms give us a positive 10y. Inside terms give us a negative 21y. And then the two last terms give us negative 35. Okay. Still going to, most of the time, combine those two middle terms. So we end up with a really ugly 6y squared minus 9y and then minus 35. So again, still going to get the correct answer, just maybe looking at it in a different light. And then also adding correctly and realizing that that is a negative 11y and not negative 9. Just trying to make sure you're paying attention, right? That's our good excuse. Okay, so here we go. We're going to try FOIL again. Understanding these are the first terms of each binomial. And then these are the outside terms of the binomials, the insides, and then the last. Sometimes it is nice to have different types of strategies for different types of students. So we have 8a squared, and then we have negative 36a. We have negative 10a, and then we have a positive 45. So bringing that all together and making sure we add correctly, we have 8a squared, we have a negative 46a, and we have a positive 45. So with that in mind, again, when are we multiplying? When are we adding exponents? When are we actually adding the terms together? So really do stay focused with how to solve these. Okay, many guided practice here to practice with, so go ahead and work on guided practice 2. And there they are. One comment with my mess up here, not knowing how to add together. Do slow down and make sure that your addition and your subtraction is correct, because when we start dealing with some pretty intense high-level concepts in next chapter, one little mess up like that, saying that negative 20 plus 6 is negative 26, is going to put us at a standstill and we won't be able to solve the problem. So again, this is a lot of rote work that we're just drilling and practicing, but we have to be very good at it in order to do some high-level problems, like this real-world example 3. Okay, so let's look at this. It says the contractor is building a deck around a rectangular swimming pool. The deck is X feet from every side of the pool. We're supposed to write an expression for the total area of the pool and the deck. Well, we know the area of the pool. We know that that's length times width, so it's 20 times 15. But they want us to include on this deck as well, and we're not quite sure how big it is. Well, let's look at the total length of this right here. We know that it's 20. We know that we have X here, and we know that we have X here. So altogether, that's 20 plus 2 X's. Now let's look at this right here. Kind of same concept. We have 15 here. We don't know the length here, and we don't know the length here. So together, that's 15 plus 2 x's, not just one because we have an x on each side of the pool. Okay, now let's go ahead and look at area. Area equals length times width. Well, we know length is 2x plus 20, and we know width is 2x plus 15. Okay, write an expression. Again, these type of problems to start with, we are not going to get a very nice answer because we are going to have some variables involved. But they did say write an expression. So length is 2x plus 20 times width, which is 2x plus 15. And now we know what to do. We know that, again, these are two binomials. So we're going to be doing some multiplying and combining terms. Okay, so our 4x squared, our outsides are positive 30x, our insides are positive 40x, and then our last is 300. Okay, combining like terms, our two middle terms. Again, what are we trying to do? We're writing an expression for the total area of the pool and deck. So we have the total length of the pool and deck, the total width of the pool and deck. So if we go ahead and combine these, it looks like we have our answer. 4x squared plus 70x plus 300. Okay, how is this going to help us? Well, if the contractor comes and says, okay, we are going to make this walkway 6 feet, then we know that we could plug 6 feet in there and figure out the total area quickly. All right, so with that in mind, go ahead and try guided practice 3. Okay, and this is what we get. Sometimes they give us a picture, other times not, so drawing out a picture really does help. Using that one up there, all we did was extended the length and width a little bit. Again, why do problems like this? A lot of times contractors are going to use what are called algorithms or programs in order to set up problems like this, just to kind of mess around with the area and mess around with the length and see what that's going to do versus cost of concrete or cost of wood. Okay, if you remember, we talked about now we're going to multiply polynomials. Last time it was binomial by binomial, now it's polynomial by polynomial. So a little bit more expensive. Again, now we can't use the FOIL method, but we're going to keep in mind the distributive property. That 2x is going to have to multiply by all 3 of those terms. That 5 is going to multiply by all 3 of those terms. So again, we're setting up 6 little mini exponents. Here we have 12x to the third, negative 18 x squared, negative 30x. Multiplying the 5 through, we have positive 10x squared, we have negative 15x, and we have negative 25. Take your time on that. Now let's go ahead and combine like terms. We actually have some x squareds now, and we have just the variable, or the x's. So altogether we have 12x to the third. Let me see, what do we have here? We have negative 8x squared. We have negative 45x. And we have a negative 25. And again, why take your time on that? Because when we start combining like terms, if we've multiplied incorrectly, we're going to get the wrong answer here. So going through all of those steps to be off by just a couple numbers is a bit frustrating. Okay, look at B. We are now multiplying a trinomial by a trinomial, which means we are distributing 3 terms through that trinomial. So first term we're distributing. This is where the arrows really do help, because this does help us focus on what we're multiplying through. Whoops. So that 3y is being multiplied by each piece. Okay, so even though it might take a little bit of time to set up, it is worth it. Now look at this, this negative 1, I'm going to have to go like this, is being multiplied by all three of those. Looks like a firework mess. All right, here we go. Let's focus on that too. We have 6y to the fourth. We have negative 10y to the third. And we have a positive 4y squared. And I know I'm going to run out of room. Oops, please don't do that. Okay, now we have a positive 9y to the third. We have a negative 15y squared, and we have a positive 6y. Now we have a negative 3y squared, a positive 5y, and a negative 2. Okay, last step then, let's go ahead and combine some like terms. We have a y to the third and a y to the third. We have 3y squareds, and then we have a couple y's. So 6y to the fourth. What do we have here? We have a negative y to the third. We have 4y minus 15y, so negative 11y. Where's your other one? Y squared. So negative 11 minus 3 is negative 14y squared. Down to y's. We have a positive 11y, and then a minus 2. And isn't that a lot of fun? Okay, so those type of problems, yes, they do take just a little bit of time, a lot of organization and focus in making sure that we're multiplying correctly and we're adding correctly. Okay, go ahead and give a couple of those a try on your own. And there they are. Remember that many of these sections end with some pretty high-level concepts. So again, when we're multiplying polynomials, many of the times it's going to be multiplying a binomial by a binomial. So if we understand that horizontal method, that vertical method, or the FOIL method, you should be good to go. But then understanding how to simplify a problem like this is also beneficial. Okay, go ahead and try the assignment for this section.